Hello everyone, Anirudh here. I am a third year undergraduate student of the Department of Computer Science enrolled in the BTech course of Indian Institute of Technology, Kharagpur. Right, I graduated in 2021 and secured a rank of 237 in JEE Advanced. Right, and I'm a resident of Chennai. Today we'll be dealing with NCERT class 11, chapter 13 of maths, that's statistics. Right, and statistics is basically the data process, how you deal with, how you segregate data, and how you get meaningful results out of a collection of hard data objects, right? How you make classes out of it, how you denote what the data is, how you get a central measure of what the data is about, and how you compare different sets of data and what are the tools you use to do that, right? So this builds upon some of the more general statistics that you would have heard about, right? Your general making of histograms, bar graphs, etc., right? Those things you'll just be looking into it a bit more in detail, right? Because in those cases, what you have learned is the mean, median, mode, three measures of central tendency of data, right? And you would have heard about the range of data. You would have heard about I think that's it. So now what you're going to deal with is the more nuanced perspectives of how this data is going to be arranged, right? Because even though the mean, median, and mode of two data sets may be the same, its ranges may be the same, but the variation that the data holds in itself, that differs. That's called the variance, right? And with the variance comes another data process called the standard deviation, right? The deviation of each member of the data class as measured from the mean, right? Those things are easy to qualify what the spread of the data is about the mean or the median or some other measure of central tendency, right? It's called the measure of dispersion actually. So you have four measures of dispersion: that's range, quartile deviation, mean deviation, standard deviation, right? The mean deviation is basically the deviation from the mean, right? You basically do x minus a, and then you just sum of all these values divided by number of observations. That's basically your mean deviation, right? Then you have your quartile deviation, right? Where's quartile? These are all mean deviations about means, and then different mean deviations for different types of data sets, right? And then mean deviation about medians, right? So that's all there is over here, right? So you have your mean deviation about means, you have mean deviation about medians, and you have a short blurb about the quartile deviation and the standard deviation, right? All right. So I'm not really going into detail about all this because that's going to take a lot of time. So just read through the text over here, because there's a lot of information that you have to know to actually qualify yourself as a statistician, right? Because they are pretty much important when you want to deal with probabilities, statistics, grouping of data, whatnot. Right? So we jump into exercise 13.1 over here, right? Sorry for that. Exercise 13.1. We have the first question being about the mean deviations about the mean for the data sets given. So question number 1. Your data set is basically 4, 7, 8, 9, 10, 12, 13, and 17. Right. First things first, know that for the mean deviation above the mean, you have to find the mean of the data. All right. So first of all, you need to find the mean, right? The mean of this data set, that is going to be this. We have 4, 7, 8, 9, 10, 12, 13, 17. I'll represent the mean as represent the mean as small m, right? We don't want to get confused. So that's going to be small m is equal to sum of all the data members, right? Sum of the observations divided by number of observations, right? We know that the number of observations, and we know that the sum of observations is basically 4, 7, 8, 9, 10, 12, 13, and 17. Right. That's going to be 4, 7, 11, 11, 8, 19, 19, 9, 28, 28 and 10, 38, 38 plus 12 is 50, 50 plus this is 30, so we get 80 over here. And this is basically equal to 10. Right, that's it. So now we make a table that shows the spread, right, about spread of the data above the mean. So basically, if I denote this as xi, and then I'll write this as xi minus x bar or xi minus m over here, right? And then I'll write this to be the absolute value of xi minus m, right? Because for the final, for the final mean deviation, you don't just sum up all the xi's minus m. You make you sum up the absolute values of all these xi minus m, because for some bits of data, your data values is going to be lesser than the mean. So if it's perfectly symmetrical, then you will get a zero value, and which is actually not possible because there is a non-zero spread. It's not just the same number being repeated again and again, right? As is what a zero deviation is going to represent. So we have 4 over here. This is since m is 10, I'll basically write this as minus 6, right? It's 4 minus 10. So here it becomes a 6. Similarly, this is a 7. I'll have a minus 3 over here, and this is going to be plus 3. This is going to be 8 and 9. This is going to be minus 2 and minus 1. So over here it's going to be 2 and 1, right? Extending table, 4, 7, 8, 9, 10, 12, 13, and 17, right? Then since the mean is 10, this is going to be a 0. Here it's going to be a 0. 12 is going to give a 2 over here. 13 is going to give a 3. 3, 17 is going to give us 7, right? Summing of all this, the sum of mod xi minus m, right, is going to be equal to, this is 237, that is 12. Here it's 1, 2, 3, 6, that is going to be 12. 12 and 12 is going to give me 24. All right. So the final, the final answer, that is the mean deviation, MD above the mean, small m, is going to be equal to, this is sigma of mod xi minus m divided by the number of observations, right? The spread above the mean divided by the number of observations. That is equal to, is basically 24 divided by 8, that is equal to 3. And that's your answer. All right. That's question number 1. Question number 2. The data set is 38, 70, 38, 70, 48, 40, 42, 55, 63, 46, 54, and 44. 54 and 44. Right? Writing this in Python list would be easier, I guess. But it is. Yeah, so we have this list, right? Following the same process as above, I'm going to write the mean small m, right? You will notice that over here is given by x bar, but you can also write it as small m, that's no big deal. Right? But if you want, to use the textbook terminology, then it's x bar. Right? If your, if your data set is represented by the notation xi, then this is x bar. If it's yi, then it's y bar. Right? Don't make the confusion by yi and x bar, because if you're going to deal with two data sets in the same question, then you're going to get confused. Yeah. Right. Having said the disclaimer, let's just proceed with the question. This is going to be sigma of xi divided by n, right? Which is basically equal to, this is right. I'm not dealing with the whole 38 plus 70 plus 48 thing. Right. I'm going to directly write the answer as 500 divided by, and this is 10. So I'm going to get the mean as 15. All right. So now again, drawing the table, right? This is xi. Then this is xi minus 50, or xi minus small m, right? And this is modulus xi minus 50. So now we have 38, 70, then 48, then 40, then 42 as the first five numbers, right? And 38 minus 50 is basically minus 12, 70 minus 50 is 20, 48 minus 50 is minus 2, 40 minus 50 is minus 10, and 42 minus 50 is minus 8. Taking the absolute values, this basically becomes 12, 20, 2, 10, 8. Right? And then the last five numbers, that is 55, 63, 55, 63, 46, then 54 and 44. 54, 44, right? So doing the minus 50 thing, I'm going to get a 5, I'm going to get a 13, I'm going to get a minus 4, and then a plus 4 and a minus 6. Taking absolute values, I have 5, 13, 4, 4, and 6. Right? Summing up all this, sigma of f, right? I just categorize this to be, f is equal to, or fi, because we have xi over here. This is fi, right? So I'll have a summation of fi being equal to, this is what 12, 20 is 32, 34. This is a 44, then a 52. 57, this is 60, this makes it 70, 78, and then this is 84. Right. So finally, we have the mean deviation about the mean to be equal to sigma of mod xi minus m divided by n. Right. This is basically sigma fi. Right. So I'll write this as 84 divided by 10, which is 8.4. All right. That we complete question number 2. Going to question number 3. In question number 3, we are finding the mean deviation about the median. Right? You can find the mean deviation about any measure of central tendency, but it's usually the mean of the median because the mode is a special case. All right. So now for exercises 3 and 4, we are going to be tailoring the mean deviation formula for the median instead of the mean. And I hope everybody remembers the median calculations, right? Because if you don't, then that's going to be big trouble. For the third question, we have the data set 13, 17, then 16, then 14, then 11, a 13 again, and then a 10, a 16, 11, and 18, 12, and a 17. So arranging this data set, this is basically the data set of, if I, such as enclose it within two square braces. This is basically equal to the data set of 10, 11, 11, 12, 13, 14. Then I have, wait a minute, I have two 13s. So this is not a 14, this will be a 13 again. Right? Then I have a 14, then I have two 16s, then two 17s, and an 18. Right? So I can basically see that for this data set, the two central values are 13 and 14, right? Since this is an even number data set, the median is going to basically be the mean of these two values, right? So the median, capital M, is going to be equal to 13 plus 14 divided by 2. That is going to be equal to 13.5. Right? And that's the measure of central tendency that we're going to be using. So over here, what I've basically done is, this is arranged in ascending order, ASC order. Right? That's what I've done. There is no big change between this data set and this data set. Right? The median then becomes trivially easier to find. You just have to find the two central numbers, take the mean, and then you get the median. That's 13.5. Right? So we go ahead with drawing the table, right? Or if you are, very much well versed and you are very confident in your maths, you can just proceed without drawing the table also. So this is going to be xi minus capital M, and this is going to be fi is equal to mod of xi minus capital M. Right. Your xi then is going to be 13, 17, 16, 14, 11, 13. And over here, since the median is 13.5, just directly subtracting it, right? 17 minus 13.5 becomes 3.5. This is 2.5. This is 0.5. This is minus 2.5. And this is minus 0.5. Right. On the modulus side, this is going to give me 0.5. This is going to be 3.5. This is going to be 2.5. This is going to be 0.5 again. This is going to be 2.5. This is going to be 0.5. Right. And then the last 6 numbers, right, which are 10, 16, 11, 18, 12, and 17. 18, 12, 17. Right. 10 is going to give me a minus 3.5. 16 is going to give me 2.5. 11 is a minus 2.5. 18 is going to be 4.5. Right. 12 is going to be minus 1.5. And 17 is again going to be 3.5. Right. So extending this over here, I'm basically going to get a 3.5 or 2.5, another 2.5, a 4.5, a 1.5, and a 3.5. Right. So summing all of this up, sigma fi is going to basically be equal to the sum of all this, all these different stupid numbers, right? Which is basically 28. 10, of course. All right. So finally, I have the median, mean deviation above the median is equal to this whole summation, right? Xi minus M divided by the number of observations. That is going to be 28 divided by 12. That is going to be equal to, this is 2.333. Right. It's a recurring decimal, but if you just leave it off after 3 decimal places, that's okay. Nobody cares. Cool. So that is going to be half the work in these kind of questions is basically drawing this table, summing them up, and doing that without a calculator, because just have to handle huge amounts of data. That's it. Cool. Number 4. The data set is basically 36, 72, 46, 42, then 60, then a 45, a 53, another 46, a 51, and a 49. Good. So first things, arrange in the ascending order. That is basically 36, then comes a 42, then comes a 45, then there are two 46s, then I have a 49, then a 51, then a 53, a 60, and then at last it's 72. Right. So we can basically say that the median is the mean of these two figures, right? That's 46 plus 49 divided by 2. That is 95 by 2, that is 47.5. Right. Or if you're more clever, you can basically see that the difference between 49 and 46 is 3. 3 by 2 is 1.5. Adding 1.5 to this or subtracting 1.5 to this is going to give you the median. You can do the median anyway, right? Both ways are both ways mean the exact same thing, right? It's just a matter of being clever. That's it. So yeah, you have found the median, right? Then comes drawing the table, right? I'm not labeling this above again. All right. So we have 36, we have a 72, we have a 46, we have a 42, a 60, then 45, 53, 46, 46, 51, and 49. Right. This is xi minus, this is basically xi minus capital M, that is 47.5. Right. 36 minus 47.5 is negative 11.5. This is wait, 48. 48 is a 0.5. Then you have 4 to 52. Then this is 24.5. Right. 46 is going to give me a minus 1.5. 42 is going to give me a minus 5.5. 60 is going to give me plus 12.5. 45 is going to be a minus 2.5. 53 is going to be plus 5.5. 46 is again a minus 1.5. 51 is a plus 3.5. And 49 is going to be plus 1.5. Right. So I'm going to have basically 111.5, a 24.5, a 1.5. This is supposed to 46. Yeah. 46 is a 1.5, 42 is a 5.5. Right? 60 yields me a 12.5. Then I have 45 giving me 2.5, 53 giving me a 5.5, then 46 giving me a 1.5 again, 51 giving me a 3.5, and 49 giving me a 1.5 again. Right. So basically, I'll have sigma fi being equal to, this is 70. 0.0 of course. Right. So finally, I have the mean deviation above the median to be equal to the sigma fi divided by n, which is 70 divided by 10, which is 7. 0.0. Right. You can drop the 0.0, you can write the 0.0, does not matter. Still means the same. Cool. Remember that MD is mean deviation. MD of whatever over here means that it is mean deviation about the measure of central tendency. All right. That's the notation that's used. Question number 5. Now, instead of ungrouped data, you're dealing with grouped data. Right. And since NCERT people are really kind, they've given us the XIs and the FIs. So that our work is really simple. We don't really need to deal with classes to find out XIs of those classes and then FIs and then do. Right. And just basically proceed. Yeah. This yeah. So what I'll do is I'll basically draw this as a table itself. All right. So this column will be XIs. This column will be for FIs. Right. And then the other columns I'll be filling as and when I go there. So first things first, we have 5 classes of data. So we have XI being 5, 10, 15, 20, and 25. Cool. And the FIs correspondingly are 7, 4, 6, 3, and 5. Right. Remember that for these kinds of data sets, your mean is basically sigma FISI divided by sigma FI. Right. So we anyway we'll have to find the product FIXI for the mean. Right. And we have to find the deviation over the mean. That's it. So we have this to be 7 into 5, that's 35. This to be 4 into 10, that's 40. This to be 6 into 15, that's 90. This to be 3 into 20, that's 60 again. Right. There's no other. This person 67. Whatever. And this is 5 into 25, that's 125. Right. So the sum of FIXI, sigma FIXI is equal to, this is 100. This is another 125. 125 is 250 and 100 is 350. Right. And you have the summation of F, that is capital N, is equal to 7, 4 is 11, 11, 6 is 17, 17, 3 is 20, 25 is 25. right? Therefore, the mean X bar is going to be equal to 350 divided by 25. That is, if I'm not wrong, that is 1, 4. Right? That's 4. So we have found X bar, right? For the measure of central tendency, for the mean deviation above the mean, what we have done over here is basically xi minus n, right? But what we have to do here is actually, fi times xi minus x bar, right? Because that is summation of that will give us this kind of a value, right? Sigma xi over here is basically sigma fi into xi over here. Cool. So with that in mind, instead of calculating the different mod xi minus x bar over here, I'll basically do that in a single step, right? Because I don't want to waste your time and my time. So this is going to be fi times mod of xi minus x bar, right? Which is basically 7 times. This is 7 into 5 minus 14, right? This is 7 into 7 into mod of 5 minus 14, which is 7 into 9, 60. Right. This is 4 into mod of 10 minus 14. That is going to be 4 times 4, that is 16. Right. This will be 6 times mod of 15 minus 14. Since this is 1, this is going to be 6 into 1, that's 6. And then this will be 3 times 20 minus 14, 20 minus 14. This is 6, 6 into 3 is 18. Right? And finally, this is going to be 5 times mod of 25 minus 14. That is 5 into 11, that is going to be 55. Right? Summation of all this is going to be equal to, this is 63 and 16 gives me a 79. This is going to be an 85. Right? 85 plus 5 is 90. 90 plus 50 is 140. 140 plus 18 is going to be 158. Right? Therefore, your mean deviation about the mean x bar is going to be equal to sigma of fi times mod of xi minus x bar divided by sigma fi, right? Which is equal to 158 divided by this is 25. So this is going to be 6 point, this is 8 by 25, which is 32 by 100. So this is 6.32. And that is your final answer. Cool. So now you have question number 6. Right. Again, dealing with group data, mean deviation above the mean. So I'm going to draw a very similar table to the one above. So I'll have the headings xi. I'll have an fi. I'll have the header xi times fi. And I'll have the header fi times mod of xi minus x bar. Again, we have 5 classes. That is 10, 30, 50, 70, and 90. So we have 10, we have 30, we have 50, we have 70, we have 90. Then your FIs are 4, wait, this is 24. This is 24. Then you have 28. Then you have 16, and then you have 8. From this, it's easy to calculate XIFI. This is 40. This is 720. This is going to be 28 fives are 140, I guess, right? Yeah, 28 fives are 140. So this is going to be 1400. 16 into 7 is 112. So this is going to be 1120. And 8 nines are 72. So this again going to be a 720. Cool. So the sum of FIs is going to give me capital N. That is, if I'm not wrong, this is 4 plus 24 is 28. 22 is 56. 56, and this is the 24. That is going to give me an 80. Right. And this is sigma xi, fi xi. this is going to be equal to, this is 720 to 2, that's 1440. This is plus 1400 gives me 2840. Plus 40 is 2880. And that plus 1120 is going to give me 4000. Exactly 4000. Right. So therefore, your mean is going to be equal to this divided by this. I'm directly cancelling, right? I'm not writing the step. So your mean is going to be 50. Cool. Therefore, this is going to be 4 times. This is 10 minus 50, right? A modulus, which is going to be equal to, this is 40. 44s are 160, right? This is 24 times 20 minus 30 minus 50, right? 30 minus 50. This is 24 and 20. That is 480. All right. This is going to be a 0 because your xi itself is 50. The mean is also 50. 50 minus 50 is going to be 0. 0 to anything is 0. Right? I'm not calculating anything. Directly putting a 0 over here. Right? And then this will be again 16 times 70 minus 50. Right? That is 16 and 20 again. That is going to be 320. And finally, this is going to be 8 times 90 minus 50. That is going to be 8 times 40, which is another 320. Right. So the summation of this is going to be 320, 320 is 640. 640 and 160 is 800. Right. 800 and 480 is 120, 1280. Finally, your mean deviation above the mean is going to be equal to the summation of fi times xi minus x bar divided by capital N, which is basically 1280 divided by 80. Right, 0 cancels out, and 128 by 8 is basically 16. Right, and that is a measure of your mean deviation. That completes question number 6. Right. Question number 7 and 8 deal with the mean deviation above the median for the given data sets. Again, class of data, right? Remember how you find the median, because I'm going to be rushing through that part. Right, this is going to be xi. This is again an xfi. Right, the rest of the things I'll fill in as and when I go there. So the data is 5, 7, 9, 10, 12, and 15. Right, unequal data classes. Be sure that you look at all these parts when you deal with the data. Cool. 5, 7, 9, 10, 12, 15. And the corresponding FIs are 8, 6, 2, 2, 2, and 6. Cool. The cumulative frequency for the data set is basically, this is 8. 8 plus 6 giving 14. 14 plus 2 giving 16. 16 plus 2 giving 18. 18 plus 2 giving 20. And 20 plus 6 giving 26. Right? Which means that, this is a 26, not 66. Right? The net frequency or the number of observations that we have is basically 26. Cool. So we have the net frequency is 26. So n by 2 is 13. Since this is an even number, right? Your median is going to be the mean of this value and the n by 2 plus 1th value, right? So we have 13th value, we have the 14th value, for which if you take the mean, you get the median capital F, right? Notice that until xi is equal to 7, the frequency becomes 14, right? Add xi, the cumulative frequency of xi equals 7 is 14. So both the 13 and the 14th value come over here, right? Because they are both greater than 8, but they are both less than or equal to 14. So for the 13th and the 14th value, we have xi is equal to 7. So basically, your median m is going to be equal to 7 plus 7 divided by 2, that is equal to 7. Fine. That makes it really simple for us, because else they'll have to take different sets and then take the different values, right? For which I have to take the mean. That's one extra step, but still bigger. Is the principle that matters, right? Anyway, the next header is going to be fi times xi minus m. Right? Having two steps, because I'm not going to write xi minus m and then fi this again and again in different columns. So this is fi into xi minus m. Remember that the median is 7. So this is actually 8 times 5 minus 7, right? 5 minus 7. That is going to be 8 times 2, that is 16. Cool. Since the median is 7, xi is 7, this is 0, right? This is going to be 2 mod 9 minus 7, right? That is 2 into 2, that's 4. We have over here 2 mod 10 minus 7, right? That is going to be 2 into 3, that's 6. Over here, again, it is going to be 2 mod 12 minus 7. That is going to be 2 into 5, that is 10. And over here, lastly, we have 6 mod. This is 15 minus 7. Right? That is going to be 6 into 8, that's 48. So we have the cumulative sum being 16 plus 4 is 20. 20 plus 10 is 30. 30 and 48 makes 78. 78 plus 6 is 84 again. Cool. Therefore, we have the mean deviation above the median being equal to the sum of mod xi minus n into fi, right, whole divided by capital N, which is basically equal to 84 divided by, this is what, 26, right? 26, which is which gives us 3.23. 3.23, right? 2 decimals is enough, not even 3. If you want extra precision, you can give out 4, but more than 4 is strictly not necessary, right? You don't need to calculate it in the heat of the exam. 3123 is going to be the final answer for question number 7. Then going to question number 8. Find the mean deviation above the median for the data in exercises 7 and 8. Cool. Yeah, so this is again uneven data classes, right? This is your exercise column, that is going to be 15, then 21, then 27, then 30, and then 35. Right? Corresponding frequencies are 5 being 3, 5, 6, 7, and 8. The cumulative frequencies then are 3, 8, 14, 21, and 29. So your net n is going to be equal to 29. Right? Which is odd. So basically, your n plus 1 by 12, that is going to be 15, right? Your 15th term is going to be the median. The 15th observation falls in this class, right? Because up till 27, we have completed 14 observations. The 15th observation comes in the 30th, the class of 30, right? Which means that your median m is going to be 30. Well, therefore, I'll then find the columns of fi times xi minus x bar, right? And I'll not, this time I'll not write mod of xi minus x bar. Right. You have to note that x bar is 30. Right. Wait a minute. This is not x bar. I'm very, very sorry. This is capital M. Right. Yeah. And then let's take over here. This is capital M. Right. I'm not going to write the expanded form. All right. So this will be 3 times. This is 15 minus 30. That's going to be 15 because we have an absolute value. 3 into 15 is going to give me a 45. Right. This is 5 and this is 21. 21 minus 30 is basically minus 9. Absolute value of minus 9 is 9. 9 into 5 again is 45. 45. Right. This is 6. This is 27. 27 minus 30 is minus 3. Absolute value of minus 3 is plus 3. 3 into 6 gives me 18. All right. And then 30 minus 30 is 0. 0 and everything is 0. 35 minus 30 is plus 5. 5 into 8 is 40. So the summation of this is going to be 45, 45 is 90. 90, 40 is 130. 130 and 18 gives me 148. All right. So your mean deviation of the median is going to be equal to sigma fi times mod of xi minus m divided by capital N, which is basically 148 divided by 29, right? Which is 5 point. 7.8 divided by 29, right? So this is 5.103. And that's the answer. There we had xi is given, right? NCERT was kind to us. Here, NCERT is not kind, right? We have the classes themselves from which you have to find out xi's and then we have to do things, right? Remember that if you have the classes like this, xi is basically the lower plus higher divided by 2, right? Fine. So question number 9, right? For 9 and 10, we are again finding the mean deviation over the mean. So we have to basically find the mean first and then proceed with whatever is given, right? The process is the same. The only the way that that you find it is quite different. So we have your the different classes and the different frequencies. First things first, I'm not going to write the classes. I'm going to directly get exercise from these classes and I'm going to write it in this table format. Cool. And then I'm going to figure out what is XIFI. From that, I'll figure out the mean. And then finally, I'll do Fi times mod of x minus x bar, xi minus x bar. And then for which I'll sum over all the values. I'll plug it in the formula and then I'll get the mean deviation. Yeah. Right. So we have first class is 0 to 100. Right. Remember that xi is basically the midpoint of this class. That is 0 plus 100 divided by 2. That is 50. For 100 to 200, same way, 100 plus 200 is 300. 300 by 2 is 150. Right. Then that means that each of these classes is the midpoints is going to basically be 50, 150, 250, 350, and so on up to 700. So I'm going to basically write that. This is 250, then you have a 350, then you're going to have a 450, a 550, a 650, and a 750. $600. Cool. All right. So, and then we have the number of people being 4, and then an 8, and a 9, a 10, a 7, a 5, a 4, and a 3. Finally, we have XIFI, right? Or instead of actually XIFI, what we can do is the step, the step deviation format, right? Step UI being equal to, right? Instead of this being XIFI and this being the whole thing, right? This is going to give me a very big value. So instead of doing that, what I'll do is I'll take the steps of UI being equal to this xi minus one of these values, right? I'll select 350 because that is pretty much at the center along with 450. You can choose any one of these. right? Xi minus 350 divided by the range of each class, that is going to be 100. So I'll then have a fi ui over here, and I won't populate the last column because I'll just come to that when I'm ready. So we have ui's being this, and ui's are going to basically be 50 minus 350, that is going to be minus 3. Then this is going to be a minus 2. It's going to be minus 1. This is going to be 0, 1, 2, 3, and 4. Right? And fi ui's are going to be minus 12, minus 16, minus 9, 0, 7, 10, 4 into 3 is 12, and 3 into 4 is again 12. Yeah. This is going to add up, and sigma fi ui is going to basically be 4. That's it. Because the positive part is basically 17 plus 24, that's 41. And the negative part is 12, 16, 28 plus 9 is 37. Right? 41 minus 37 is 4. This is your answer. Cool. But your mean X bar is going to be what? 350. I think this, wait a minute. Yeah. This is going to be 350 plus this is sigma of fi ui, right? That is going to be sigma fi ui divided by capital N into 100, right? That's a plus sigma fi ui divided by n into h, right? Where a is 350 over here, h is 100. H is the height of each class. And from this, you can basically find that n is what? 4, 8, 12, 9, 21. 21 plus 10 is 31, 38, 43. And then we have a 7. So this becomes 50. Yeah. So we have this to be 350 plus 4 into 100 divided by 50, which gives me a 2. 204 is 8. 8 plus 350 is basically 308. 308. And this is your mean. Cool. So we have found the mean. And finally, we have fi times mod of xi minus x bar to be calculated, right? Because that is what gives us the mean deviation. So this is going to be 4 into mod of 50 minus 358, 358, right? That is going to be 4 times 308, which is 1, 2, or 3, 2, right? Similarly, over here, this is going to be 8 into 150 minus 358, right? Which is going to be 8 times 208, right? This is going to be 8 into 208, which is equal to, this is 1600 and 8 is 64. So we have 166. Then this is going to be 9 into 250 minus 358. That is going to be 9 times 108, right? 9 into 108. That is going to be 970, right? This will be 10 times 10 times 8. 10 into 8. That is going to be 80. And again, this is going to be 7 times 7 into 108. That is going to be 756. Then you will have 5 times 208. 5 into 208. That is going to be this is 1040. So we have 1040. Then you will have 3 times 308. 3 into 308. And you will have 4 into, you'll have 3 into 408. Wait a minute, this is 4 into, I'm sorry. This will be 4 into 308. Right? Yeah, 489 7543. Right. So we'll have this, which is 4 3 is 12, right? 1232 again, 1232, and this will be 1224. And all this will sum up to give me 7,800. Wait a minute. 7 digits. Oh, wait. I've made a mistake. I'm sorry. I'm very sorry. It's not 108, but this is going to be 102. Right? All this is going to be 102, 202, 302, 402. Because it's 450. Wait, it's 450 minus 358. So it's not even 102, but it's 92. Going to be 92, this is going to be 192, this is going to be 292, and this is going to be 392. So all these figures are also wrong. Right? 7 nines are 63, 630 and a 14, that is going to be 644. Then I'll have 5 into 192, right? 19 plus 95. So I'll have a 960 over here. This is 4 into 292. 29 fours are, it's going to be what, 116, right? So this is going to be 1168. And this is going to be 43s are 120. So it's 117. So 1170, 1176, 1176. Right. Therefore, this sum is going to give me, a sum is going to be 7,896. That's it. Right. Therefore, your mean deviation above the mean x bar is going to be equal to summation, this summation. And I'm not writing the formula down. We all know the formula is going to be 7896 divided by the net number, that is 50. Right. Remember that this is basically 7,900 minus 4. Right. And 7,900, right, it's basically 790 by 5 minus 0.08. Right. 4 by 50 is 8 by 100. That's 0.08. Which is, this is basically 158. Right. So it's 157.92. That's the answer. $157.92. Right. Question number 10. Right. Very similar procedure. I'm not changing anything. So first, we're going to write exercise. Right. Very simple because they have given us intervals of 10 and they have started off with a 5. So we all know that it's basically 95 plus 5, 105 plus 5, 115 plus 5, and all cuts are equal in size. So there's no issues at all. Right. So I'm basically writing on the exercise as 100, then 110, then 120, then 130, 140, and 150. Because there are 6 classes, right? 1, 2, 3, 4, 5, 6. And I have the FIs to be 9, 13, 26, 30, 12, and a 10. Right? UI, let UI equal xi minus, I'll select this value, 120 again. Cool. So let that be xi minus 120 divided by 10. That's class size. Right? So this is basically going to be minus 20 by 10. That's minus 2. This is minus 1. This is 0. Then it's 1, 2, 3. Right. So FIUIs then are going to be minus 18, minus 13, 0. This is going to be plus 30. This is going to be plus 24. And again a plus 30. Right. This is basically minus 31. This plus this is minus 1. 30 plus 24 is 54. 54 minus 1 is basically 53. Sigma is 53. Right? And sigma Fi is basically n, which is 10, 30 is 40. Then you have 25, that's 65. 65 and 35 gives me 100. So we have the mean x bar to be equal to your A, that is 120, plus this sigma 53 divided by this n, that is 100, into the class size, that is 10, right? Which is basically 125.3. That's it. So since we have found the mean, we basically have the final column to fill, that's fi times mod of xi minus x bar, right? Since this is 125.3, and up till 120, we can just basically blindly put the values, right? It's 9 into 25.3, 9 into 25.3. Then you have 13 into 13 times 15.3. Then you have 26 times 5.3. Right. After this is where it gets a little bit trickier. Right. 130 minus 125.3 is 4.7. So we have 30 times 4.7. 30 into 4.7. Then you have 12 times 14.7. And finally, you have 10 times 24.7. Right. And you have to calculate this in blocks also. This is the easiest. This is basically 247. Right. This is second easiest. 47 into 3, that's 141. 40 into 3 is 120. 7 into 3 is 21. 120 and 21 is basically 141. Yeah, so, and then finally we have all the rest of the stuff. This is going to give me 227.7, if not wrong. Right? This is going to be 198.9. This is going to be 137.8. And this is going to be 176.4. So your sigma is going to basically be 1128.8. Right? This is a 0.4, this is a 0.9, this is a 0.7. This is 16, this is 24, this is 28. So the 0.8 is done. There is nothing follows. All right. So this is 128.8. Therefore, the mean deviation above the mean is going to be 1128.8 divided by 50, divided by 100. Sorry, divided by 100. That is going to be 11.288. This is the final answer. Right? If you want, since this unit is in centimeters, you have to write centimeters over there. Similarly, over here you'll have to add the rupees because your income is per day in rupees. Right? If you want to add per day, you can also do that. That's not strictly required, but you can do that. But do not forget the units. With that, we complete question number 10. Question number 11. Mean deviation above the median for the following data. Right? It's a bigger process. But again, some things hold true. Right? Your Xi's, your Fi's. It's going to be the first two columns. This is going to be Fi, this is going to be Xi, and then I'll have a Ca. Right. First, look at the class sizes. They are all similar. So I can basically go ahead with writing the Xi's. Right. This is going to be 5, then a 15, then a 25, then a 35, a 45, and a 55. That's it. 6 classes. Right. Corresponding FIs are 6, 8, 14, 16, 4. The cumulative frequencies then are going to be 6. 6 plus 8 is 14. 14, 14 is 28. 28, 16 is 44. Then a 48. Then a 50. Which means that a capital N is basically. Now, what we class the level containing the n by 2th item, right? N by 2 is 25, right? And 25 comes in this class interval. right? The class interval for which xi is 25. That is basically 20 to 30. Cool. Because for 15, the cumulative frequency is 14, but for 25, the cumulative frequency is 28. That means that the 25th value lies somewhere over here, right? So therefore, the lower bound small l is going to be 20. The upper bound small u is going to be 30. The cumulative frequency CF is going to be 28. Yeah, for the class, it is going to be 28. The frequency of the class is going to be 40. Right? That means from your formula, your capital M is going to be equal to L plus this what? Capital N by 2 minus CF divided by F into H. Right? This is going to be 20 plus, since capital N by 2 is 25, this is going to be 25 minus the cumulative frequency CF is the CF of the above class, right, which is 14, divided by F of this class, which is 14, into H, which is 10, right? I'll remove this arrow because I'll be writing something so like that. So this is going to be 20 plus 11 into 10, that's 110. Where I just directly multiply. It's 110 divided by 14, which is 55 by 7. That is going to be a little less than 7, that's a little less than 8, right? Which is going to be 27.86. This is the median, right? Therefore, we have Fi times Xi minus M over here, right? Remember that the median is 27.86, right? So this is basically going to be 6 into 5 minus 27.86, that is 6 into 22.86. Then you have 8 into this is what? Minus 10, right? So this is going to be 12.86. Then you will have 14 into 2.86, right? And then you will have 16 into 35 minus 27.86 is going to be a plus a 0.14 and then 7, right? So this is going to be 7.14. Then this will be 4 times 17.14. And this is going to be 2 times 27.14. Sigma of which is basically, right, this is 54.28. This will be 68.17 for the 68 and 14 for the 56. Right. The other things are going to basically be 6 into 22.86 is going to give us 137.16. 8 into 12.86 is going to give me 102.88. And 14 into 2.86 is going to be 40.04. Right? And then you have 7.14 into 16. That is going to be 114.24. Finally, the sum is going to then be 517.16. Right. Therefore, your mean deviation above the median is going to be 517.16 divided by the number of 11 plus 50, which is basically, if I do 1 into 2, this is going to be 1034.32 divided by 100. So I'll move the decimal 2 places over here, which is going to give me 10.3432 as the mean deviation. Since the deviation is for marks, I'll write this as 10.3432 marks. That's it. And finally, moving on to question number 12. Calculate the mean deviation about median age for the age distribution of 100 people given below. Right? This is given in the form of an exclusive, this is an inclusive classification, right? So because we have the upper limit of each class being included in the class consideration. So what you're going to do is we know the conversion between an inclusive and exclusive class. Then you have the hint, which is to convert the given data into continuous frequency distribution by subtracting 0.5 from lower limit and adding 0.5 to the upper limit of each class. And if your class intervals are not separated by 1, but they're separated by 2 or something more, then what you do is you add the upper limit of one class and the lower limit of the other class and divide it by 2. Right? Basically take the mean of this and this, and then add that to this, subtract that from this, right? And so on and so forth for all the classes. That's something that what you do when faced with such kinds of situations. Cool. Having said that, I'll now proceed with the question. Right? I'll rewrite the data. So this is going to be 15.5 to 20.5. Right? And so on and so forth. Wait, I'll actually not do this. Notice that if you are subtracting 0.5 from this and adding 0.5 to this, right? Anyway, the mean of the class, right, or the central figure of the class, your xi, is going to find by adding this to this and then dividing by 2, it's not going to change, right? Because you have a minus 0.5 and plus 0.5, which basically cancel out to 0. So you can directly write your xi's as 16 plus 20 by 2, that is going to be what? 18, right? It's 18. And then this is going to be 21 plus 20, 38, then a 43, 48, and a 50. Right? 1, 2, 3, 4, 5, 6, 7, 8. And you have the corresponding FIs to be 5, then a 6, then a 12, 16, and 9. Xi and Fi. Right? Cumulative frequencies then become 5, 11, 23, 37. Since this is 26, then this becomes 37, 60. Then it becomes 75, 91, and 100. Right? And you're given that you have 100 people. Here it is 100. Right? With that, we go to the median calculation. Right? Remember that your median is basically calculated from the class of where n by 2 falls, right? N by 2 is 15, right? And the 50th observation falls inside this class. This is a median class, right? Your NC, right? And the median class is basically a class having the midpoint 38, which is this class, right? Where you have to subtract 0.5 from the lower limit, add 0.5 to the upper limit. So the class is basically 35.5 to 40.5. It's not basically 36 to 40, it's 35.5 to 40.5. Right. So you have the lower limit L to be 35.5. You have the height h to be, this is what, 5, right? H to be 5. So you can basically write your median as L plus n by 2 minus CF into H, which is 35.5 plus 50 minus, this is CF of the previous class, that is 37, divided by frequency of this class, that is going to be 26, into 5. Right? 50 minus 37 is 13. 13 by 26 is 1 by 2. So this, I'll write this as 35.5 plus 5 by 2, that is 2.5, which is 36 plus 2, 38. That's a median. Cool. So we basically have then that Fi times Xi minus capital M is going to be, since 38 itself is your median, this is also the median, right? We have 5 into 8 minus 38, that's 5 into 20, that's 100. Then you have 615, that is going to be 90. You have 12 into 10, that is going to be 120. Right? You have 14 times 5, that is going to be 70. You have 26 times 0, that is a 0. You have 12 times a 5, that's 16. 16 times 10, that's 160. And then 9 times 15, that is 135. The summation of which is going to give me, just a second. Summation of which is going to be 725. Right? Therefore, the mean deviation above the median is going to be equal to 735 divided by 100, which is 7.35 years. Cool. Because you have the median age, which is measured in years, so your mean deviation is going to be 7.35. That's it. That's it for exercise 13.1. And then you have the limitations of mean deviation, where they speak about the degree of variability being very high. Then the median is not really a representation of the central tendency. The mean is also not really reliable in these cases, right? So yeah, and in many cases, mean deviation above the mean is going to give unsatisfactory results because it's not really very objective. It is pretty much subjective and depends on how the data is also classified, right? Because of which, if you have a very skewed data set also, you may have a mean deviation of very little, when in fact it is actually quite high, right? Or sometimes even if the spread is quite small, right? Since the values may be large, your mean deviation is also large, so it's not really that reliable, right? In those cases, what we do is we rely on the standard deviation and the variance part. The variance is basically the square sum of the deviations of each observation from the mean, right? Divided by the number of observations. So 1 by n times sigma of xi minus x bar whole square is going to give the variance, which is denoted by sigma square, right? Taking the root of this is going to give us the standard deviation, that is sigma. Cool. Then you have standard deviation of discrete distribution. You have standard deviation of a continuous distribution, right? And then you have another formula that is going to be 1 by n root of n times fi xi square minus fi sigma fi xi the whole square. And then you have the step deviation method of which is a shortcut to find the variance and the standard distributions of the variable y. All right. So then we jump into exercise 13.2, which has 10 questions, right? Question number 1. Find the mean variance for each of the data in exercises 1 to 5. Pretty simple, right? So we have 6, 7, 10, 12, 13, then 4, 8, and 12. So your summation sigma xi is equal to 6, 7 is 13, 13 plus 10 is 23, 23, 12 is 35, 35, 12 is 47, 47, 13 is 60, 60 plus 12 is 72. So your mean x bar is going to be 72 divided by 8, which is 9. right? Then your variance is going to be sigma of xi minus x bar the whole square, which is equal to each of these minus 9 the whole square, right? 6 minus 9 is basically 3 square, plus this is going to be 7 minus 9, that is going to be 2 square, plus 10 minus 9, that is going to be 1. 12 minus 9 is going to be again 3 square. Then you have 13 minus 9, that is going to be 4 square. Plus then you have 4 minus 9 being 5 square. 8 minus 9 being again 1. And this is a 12, right? So we have 12 minus 9, that is going to be a 3 squared again, which is 9 plus 4 plus 2. I'll club this and this, give a 2, plus 9 again, plus this is the 4 square, this is 16. Then you have a 25, and then you have a 9, right? So finally we have 9 3s are 27, plus 25, that's a 52. 52 plus 2 is a 54, and a 4 is a 58. 58 plus 16 gives us 74. Therefore, the mean x bar is 9. The variance sigma square is going to be 74. Okay, that's not sigma square. This is xi minus x bar whole square, right? So we have sigma square to be 74 divided by the number of observations, that's 8, which is 9 point. I'm very sorry, it's not sigma square, right? The variance is 9.25. Question number 2. First n natural numbers. So we have, I'll use a formula directly. Okay. So for the first n natural numbers, we know that sigma xi is going to be equal to n into n plus 1 by 2, right? Therefore, your mean x bar is going to be equal to 1 by n into sigma xi, which is 1 by n times n into n plus 1 by 2, which is basically it is n into n plus 1 divided by 2n, because you have n natural numbers, the number of observations is basically n, right? So this will be n plus 1 divided by 2, right? And so the variance, right, is going to be xi minus x bar the whole square, right? Which is basically the summations of n minus 1 the whole square plus n minus 3 the whole square and so on, right? For which what you will do is that instead of finding this out, you use the alternative formula for the variance, right? Because this is going to give us like values like n minus 1 by 2 the whole square plus n minus 3 by 2 the whole square, which is pretty hard to resolve, right? Plus blah blah blah. Instead of this, what you'll do is you use the alternative formula for the variance, right? Which is sigma squared is equal to 1 by n times 1 by n times sigma of xi square minus the x bar the whole square, right? So since we have this formula, I basically find out what sigma xi squared is, right? Which is n into n plus 1 into n plus 1 by 6. So our sigma square then is going to be this by n, which is n plus 1 times 2n plus 1 by 6 minus, this is going to be n plus 1 by 2 the whole square, which is n plus 1 by n plus 1 the whole square divided by 4. Right. So multiply this by 2, multiply this by 3. We'll basically have if this is 2n square plus 3n plus 1, multiplying this by 2, I'll get 4n square plus 6n plus 2 minus, this is n plus 1 the whole square and 3, right? So this is 3 times n square minus 12, no, minus 6 n minus 3 divided by 12. 3n square cancels out to give 1n square. 6n and 6n gets cancelled, and this is going to be a minus 1. So we are basically left with n square minus 1 divided by 12. That's the answer. Therefore, for the first and natural numbers, x bar is equal to n plus 1 by 2, and variance sigma squared is going to be equal to n square minus 1 divided by 12. All right. Remember this because this is a very useful result. Right? You may use this if you are studying for higher entrance exams. Question 3. First 10 multiples of 3. So we have the data set to be 3, 6, 9, blah, 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 until 30. Pretty easy, right? Sigma xi is basically 3 into sigma of 1 till 10, right? Which is basically 3 times 10 into 11 by 2, right? Which is 3 into 55, that is 165, right? 165. So your mean x bar is going to then be equal to 165 divided by 10, that is going to be 16.5. Since this is not decidedly not a natural number, what we are going to do is that we'll be finding the variance by split deviation method, right? Because it's going to be easier when you don't have a natural number, because you don't want to deal with the 1.5 square, 2.5 square, 12.5 square. That's the pain. So what we're going to do is we are going to assume that a equals 18, right? Because it's 5 and 6. I take the bigger value. A equals 18 is the assumed mean, right? Assumed mean. So I'll just run the exercise. So I'll have 3, 6, 9, 12, 15, 18, 21, then 24, 27. Right. This is the assumed mean A. So if I have xi over here, then di is going to be xi minus A, right, which is xi minus the assumed mean. It's going to then be minus 15, minus 12, minus 9, minus 6, minus 3, 0. And then 3, 6, 9, and 12. So finally, you have di the whole square. It's going to then be 225, right? 225. Then this is going to be 144. This is at 81. This is at 36. This is at 9. This is at 0. And then again, this is at 9. This is at 36. This is at 81. And this is at 144. Because of which, sigma d square I can write as this is 18. 18 72 plus 90. 90 plus 162 is 252. 252 plus 288 becomes 290, 490, and 540. 540 and 225 is going to give me 765. Right. Therefore, d bar, right, which is sigma di by n, is going to give me, this is what all these are going to get cancelled, and minus 15 is going to be the only, only thing that's carried over, which is minus 15 divided by 10, which is minus 1.5. And, the variance sigma square is going to be 1 by n times sigma d square minus t bar the whole square, right? Which is basically 765 by 10, that's 76.5 minus this value, the whole square, which is 2.5. Okay. So this is basically 74.25, which is the final answer. Right. Therefore, for this question, we have x bar being equal to 16.5 and sigma square being equal to 74.25. All right. That finishes question number 3. Then going to question number 4. Right? We have the tabular column of Xi's and Fi's. Right? They're not classes, but they are basically repeated values of X, repeated values of repeated values, right? The repeated values of data. So classes, not classes, but data classes, because that's what they are. Xi is a 6, Fi is a 2, then for a 10 is a 4, for a 14 it's a 7, it's not 8. For 18 you have a 12. For 24 you have an 8. For a 28 you have a 4, and for a 30 you have a 2. N is equal to 2, 4, 6, 8, 14, 12, 26, 33. 33, 4 is 37, 2 is 39. Right. And 2, 4 is 6, 6, 8 is 14, 14, 12 is 26, 26, 7 is 33. Okay. Oh, wait, this is 3. Where was that? This point. So that's XIFI. Yeah. Again, right? So yeah. We'll do this by the step deviation method itself, right? Again, the central value is basically this. Let this be the S1 A. Alright. So we have DI being XI minus A, which is minus 12, minus 8, minus 4, 0, 6, 10, and 12. Right. That means FIDIs are going to basically be minus 24, minus 32, minus 28, 0. Then this is a 48, this is a 40, and this is a 36. Right. The sum of which basically this gives a 20, this gives an 8, this gives a 12. Right? 12, 8 is 20, 20, 20 is 40. Right. And the summation of Fi di squared will then basically be is 144 times 2, which is 288. This is 8 square 64 times 4, which is 256. This is 4 square 16 into 7, that's 112. This will be a 0. This is 6 square, which is 36 times 8. Right? 36 into 8, which is 288 again. Right? Then this is 100 times 4, which is basically 400. Lastly, this is 144 into 3, that is 288 plus 144. That is going to be 442. Right. Yeah, it's 430. Whose sum is then going to be 1776. Therefore, that x bar is going to be the assumed mean plus the sum of FIDI divided by n, right? Which is basically 18 plus 40 divided by 40, which is 90. And the sigma square is going to be 1 by 40, 1 by n times your sigma of FIDI. It's FIDI square, right, which is 1776 minus x bar the whole square, that is 2361, right, which is basically, oh wait, no, it's not x bar square. This is sigma FIDI by n the whole square, right, which is 40 by 40 the whole square. So this is going to give me 177.6 by 4, that is 44.4, yeah. This is 44.4 minus 1, which is 43.4. Wait a minute, it's actually not 0.2, but this one. Also, my bad. I'm sorry. So for this question, what we have is x bar is equal to 19, while the variance per square is equal to 43.1. Right? Yeah. Going to question number 5. Similar kind of question. You have xi's being tablet. You have xi's being 92, 93, 97, 98, 102, 104, and 109. Right? And the FIs being similarly 3, 2, 3, 2, 6, 3, and 3. Right? Using a similar tactic, right? Let this be the assumed mean A. That means that DIs are basically minus 6, minus 5, minus 1, 0, plus 4, plus 6, and plus 11. Right? Therefore, your FIDIs are going to be, this is minus 18, this is minus 10, this is minus 3, this is 0. And then you have a 24 and 18 and a 33. Right? While FIDI squares is going to be, this is what 36 threes are, that is 108. You have 25 twos are, that's 50. You have 1 into 3, that's 3, and 0. Then you have a 16 into 6, that is 96. You have 36 into 3, that's 108 again. And you have 11 square, 121 into 3, that's 360, right? Therefore, summing up, the first thing is the cumulative sum n, that is going to be 22, right? Because it's 3, 3, that's 6, 6 and 6 is 12. This is the set of 5 and 5, so this is 10. 10 and 12 makes 20. Right? The sum of this and the sum of this, we have to calculate. The sum of this is going to be, this is 18 minus 18 is 0. The rest is a minus 13. Over here, the rest is 33 plus 24, that's 57. 57 minus 13 is 44. Right? And so this sum is going to be 44. Yeah, okay. And this sum then is going to be this sum is going to be 108.53, which is 161 over here, right? 161 plus we have a 96, we have another 108, and we have a 363, which gives me 728. Right? All right. So now, with all this in mind, we can basically find out x bar. That is going to be a plus, that is 98, plus sigma of xi5, xi di, or dif5, sorry, right, which is 44 divided by n, that is 22, which is basically 98 plus 2, which is 100, right? And your standard deviation sigma square, right? Your variance sigma square is going to be 1 by n into sigma fi di square minus sigma of fi di by n the whole square, right? So this is basically 728 divided by 22 minus, is going to be sigma fi di, that is going to be 44 by 22 the whole square, right? Which is then going to be this is 728 by 22, right? Which is 33.091, right? Because it's 33.090909, which is which I'm shortening as 33.091, minus this is going to be 2, and 2 squared is 4, which is going to give me a value of 29.091 as my variance. Therefore, for this question, your x bar, your mean, is going to be equal to 100 exactly, and the variance sigma square is going to be equal to 29.091. All right. Fine. That finishes question number 5. Then go into question number 6. In question number 6, we have to find the mean and standard deviation using the shortcut. Right? We can't use any other method, we have to use the shortcut. So, fine. First, tabulate the data as usual. This is xi, this is fi. Right? For xi, we have 60, then 61, then 62, then 63, then 64, 65, 66, 67, and 68. Right? 9 pieces of data that I'm going to have. Right? This BDS will, because the short that we have to assume, right? So this BDS will. Given that the frequencies are 2, 1, 12, 29, then 25, 12, 10, right? We have the DIs being xi minus a, which is -4, -3, -2, -1, 0, and 1, 2, 3, and a 4. Right. From this, we have n is equal to 549. This is 22. 22 9 is 31. 31 plus 29 is going to give me 16. 16 plus 25 is 85. 85 plus 12 is 97. 97 plus 3 is 100. Right? Since we have di's, then we have di squares, which is basically 16, 9, 4, 1, 0, and 1, 4, 9, and 16. Right? Because of which we can find out FIDI and FIDI squares, FIDI and FIDI squared, right? FIDI being -8, -3, -24, -29. This is 0 in both cases, right? Then this will be at 12, this will be at 20, this will be at 12, this will be at 20. Right? Similarly, over here, this is going to be a 12, but this is going to be a 40. This will be a 36, and this will be an 8. This will be a 29. This will be 12 fours are 48. This will be 1 into 9, that's 9. And this will be 2 into 16, that is 30. Right. So we'll have sigma of this being, this is 32, 32 being 64. This is 8, 3, 11. 11, 29 is 40. 40 plus 24 is 64. So the summation of this is basically 0. And the summation of this is going to be 286. Right. Finally, using the shortcut method, right, your x bar is then equal to a plus, this is sigma FIDI, sigma FIDI divided by n, which is 64 plus 0, which is 64. 7. Right. And the sigma square then is going to be, wait a minute. Yeah. Sigma square then is going to be 1 by n, right? Is 1 by n, that is 100, times sigma of FIDI square, that is into 286, minus sum of FIDI by n the whole square, which is 0, right? Minus 0 the whole square, which is basically 286 by 100, which I'll condense down to write as 2.86. Right? Therefore, sigma, that is a standard deviation, is going to be square root of 2.86, which is at first glance a little less than 1.7, right? Because 17 squared so putting you can't really get this value through normal, what is it? I mean, if you want to really try it out, you can do the square root addition thing, but it's actually far easier to get this in a calculator, and these kinds of stupid roots are not usually asked in exams, so I don't need to really worry about that, right? But for information, this is pretty close to 2.89, right? That's 1.7. It's not exactly 2.89. So you can, if you write this as 1.69, you will be correct, right? Because its value is actually what 1.692 something, right? Not wrong. Just let me check. It's is 1.6911. So you can of course write as 1.69. Pretty fine, right? Nobody's going to care. Cool. Yeah. So we have found the standard deviation and the mean for this question, which is 64 and 1.69. Right? All right, that takes care of this question. Go to question number 7, 8, 9, 10. Right? Find the mean and variance for the following frequency distributions. Question number 7. Right. So we have classes to be 0 to 30, 30, 60, 60, 90, 90, 120, 120, 150, 180, and 180. Right. As usual, I'm not bothering the classes. I'll directly write the midpoints as exercise and go ahead with the life. Right. So this is going to be 15, this is going to be a 45, then a 75, a 105, then a 135, a 165, and a 195. 7 classes, right? Their individual frequencies being 2, 3, 5, 10, 3, 5, and 2. Notice that 2, 3, 5 is 10, 3, 5, 2 is 10, there is another 10. So your n is basically equal to 30. Right? Now I'm going to use step deviation method. Right? Ui is going to basically be, if I'll assume this to be my assumed A, right? Ui is going to be xi minus A divided by the class width, that's 30. All right. So ui is equal to xi minus 105 divided by 30, which is going to give me, this is 15 minus 105, that's minus 90 by 30, that's minus 3, this is minus 2, minus 1, 0, 1, 2, and 3. Right? Therefore, I can easily find out FIUY to be, this is minus 6, this is a minus 6, this is a minus 5, this is a 0, then this is 3, this is a 10, this is 6. Right? FIUY squared then will be, FIUY squared then will be, this is a 9, 9 2s are 18, this is a 4, 4 3s are 12, this is 1, 1 to 5 is 5, this is 0 of course, right? And then this is a 1 again, 1 to 3 is 3, this is 4, right? I'm basically saying ui squares instead of ui, right? So this is a 4, 4 into 5 is 20, and this is a 9, 9 2s are 8, right? The summation of this, summation of FIUY is then going to be, this is 6 minus 6 is 0, right? The other two giving minus 11, these two giving 13, 13 minus 11 is 30, right? And the summation of FIUY squares, that is going to be 18, 12, and 5, that is 35, 18, 20, and 3, that is 41, right? This is a 35, this is a 41, we are going to basically get this as 76. Therefore, we have x bar being a plus, this is sigma FIUY divided by sigma FI, right? This is a plus sigma FIUY divided by n, right? Into h. I should look at that, right? Which is my assumed mean is 105 plus this is 2 divided by 18 times 30, right? Which is 6 by 8, which is 0.75. So my assumed mean, my actual mean is 105, right? It's 105.75. Right? Because this is 0.75, 2 to 3 by 8. Right? Wait a minute. Oh, wait a minute. I'm really sorry. This is actually 107 because this is not 80, this is 30. Right? So this and this get cancelled. We have 105 plus 2, that is basically 107. That's our answer for x bar. Right? That means the variance is then going to be 1 by n times sigma of fi di squared, fi ui squared, right? Minus sigma of fi ui divided by n, the whole square, the whole into class width square, right? Which is equal to 1 by 30 times FIUI squared is 76, right? So this is 76 by 30 minus this is going to be 2 by 30 the whole square into 900, which is basically 76 and 30 minus 2, right? Which is if you multiply 76 into 3, you get 228. So this is 2280 minus 2, which is 227, right? And that is the variance that you're searching for. Wait. I made a mistake again. It's not 2. This is 2 squared, which is 4. So this is not 278, but it is 276. Yeah. So finally, we have the mean being 107 and the variance being 2276. All right. With that, I'll stop here for part 1. Right. The rest of the questions and the miscellaneous exercise is going to be dealt with in part 2 of this semester. Thank you for listening. Hope you have a nice day.